When a pattern is being explained, there must be enough of the pattern given to firmly establish what it is. So for a repeating pattern, the repeated portion should be given at least twice to establish the pattern. So for example, if a pattern is written as green, blue, green, it's not clear how it continues. For a growing pattern, a large number of terms must also be listed to establish the pattern. Alright, so let's take a look at this pattern here, and then try to figure out the next two numbers. So 1, 4, 7, 10, 13. Well, if I look at it from, say, the first number to the next, well, from the looks of it, it looks like I'm adding 3. So let's see if that holds up. Well, 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. Now, if I continue this on, 13 plus 3 would be 16. And then 16 plus 3 would be 19. Now, this type of pattern where you keep adding the same amount over and over and over again has a special name, and it's called an arithmetic sequence. An arithmetic sequence is a sequence in which the difference between each pair of consecutive terms is the same. So if you're going from 2, 4, 6, 8, it looks like each time I'm adding 2. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 more would be 10, plus 2 more would be 12, plus 2 more would be 14. If I go 30, 35, 40, each time I'm adding 5. So 30 to 35 is add 5, then add 5 to get to 40, add 5 to get to 45, then 50, 55, and 60. You can also think of this repeated subtraction. So I start with 60, and I'd be either, you could say either adding -3 or subtracting 3. And then subtract another 3 to get to 54, subtract 3 to get to 51. If I subtract 3 again, it would be 48, then 45, then 42. In general, if you have a starting point A, then if you add something like add D, you're at A plus D. If I add another D to it, then it becomes A plus 2D. If I add another D to it, it becomes A plus 3D. And then if I add another one, it'd be A plus 4D, then A plus 5D, then A plus 6D. All right, let's take a look at another sequence. So 1, 2, 4, 8, 16. Well, if I try this as an arithmetic, add 1, I suddenly get into problems by the time I get to the next part. So I can't just keep adding the same amount. I'm adding 1, then I'm adding 2, then I'm adding 4, then I'm adding... So addition isn't the way to go. But I can also think of this as multiplication. 1 times 2 is 2. If I multiply by 2 again, I'm at 4. Times 2 is 8. Times 2 is 16. Then times 2 would be 32. Times 2 would be 64. So this type of sequence where I'm multiplying by the same amount is what's known as a geometric sequence. So a geometric sequence is a sequence in which there is a common ratio. That is, there is something that you can multiply over and over and over again between each pair of consecutive terms. So I guess we just looked at this first one. 2 to 4 would be times 2, then times 2, then times 2, and then 32, 64, 128. 96 to 48, well, you can figure out the ratio by taking one term and dividing by the previous. It looks like that reduces to 1/2. So you can think of this as times 1/2 or divide by 2. But if I times by another half, I'm at 24. Times a half again, I'm at 12. And then it'd be 6, then 3, then 3/2. 60 to -60 would be -1. Then times by -1 again. to get the positive 60, then times by negative 1 to get the negative 60, then positive 60, then negative 60, then positive 60. So this would be an example of a repeating sequence. And then in general, I start with something A, whatever that is. I multiply by R, and then I multiply by R again. R times R is R squared. I multiply by R again. R squared times R is R cubed. And then I would have AR to the 4th, AR to the 5th, and AR to the 6th. Alright, so for these ones, they both start with the first two numbers, 3 and 12, and then it kind of goes off from there. So let's try to figure out the pattern. If this first one, if I think about this as arithmetic, I would add 9, and then I would try to add 9 again, and that's not a problem. I mean, that is a problem. So let's try multiplication. 3 times 4 is 12, times 4 is 48, and then 48 times 4 is 192. Okay, and then after that, we can just pull out a calculator. It's here. I start with 192 times 4. I get 768. And if I times 4 again, I get 3072. The next one, if I 3, 12, 21, this looks like the arithmetic will work. So plus 9 to 21, plus 9 to 30, plus 9 again to 39, plus 9 again to 48. So again, this first one is geometric, and the second one is arithmetic. All right. And for this last one, let's hide this. Tell whether each sequence is arithmetic, geometric, or neither. So if it's arithmetic, give the common difference. If it's geometric, find the common ratio. And if it's neither, then we ignore that. Well, for part A, 8 to, so if I try thinking about this as arithmetic, I would subtract 3, and then I would add 3. That's not going to work. And it's also not going to work for geometric, so this would be a neither. I mean, if I go from 8 to 3, that would be multiplying by 3/8. And then I would times it by 2. So it's neither. It's not arithmetic. It's not geometric. For part B, I would add 8, then add 8, then add 8. So this is arithmetic, where the common difference is 8. And then for the last one, 100 to 20, well, 20 divided by 100 is 2/10 or 1/5. And then 20 times 1/5, or 20 divided by 5, is 4. And then divide by 5 again, that would be 0.8. Divide by 5 again. 0.8 divided by 0.16 is, or 0.8 divided by 5 is 0.16. So this would be geometric. Geometric. Where the common ratio is 1/5.